In this lesson, we're going to learn about some exact values. Now, when we say exact values and higher, we either mean a fraction or a surd. So generally, if you see a question in a book, a worksheet, or in the exam, whatever it may be, that says give your answer as an exact value, you are looking to express your answer as a fraction or a surd. Or it could be both, it could be a fraction involving a surd as well. So you actually know some exact values from last year. We covered them right at the beginning of the trigonometric graphs topic. So if we just firstly look at the sine function, which hopefully you'll recognise that. And I'm just going to put this up here as well in radians, because obviously we need to be able to interchange between degrees and radians and degrees, and we should just be able to use radians as well as we can use degrees. So firstly, let's look at some of the values that we already know about, and then we'll go on to look at some that we maybe don't know as much about. So if we look at this graph and we want to find out the value of sine 0 degrees, or just sine 0 radians, so that's where the x value, or the theta value as it is in the radians graph, is 0. So what height is the graph when x is 0? And we can see there that on the y-axis that is also 0. Now look at 90 degrees, or pi over 2. So what height is the graph when x is 90, or theta is pi over 2, and that is 1. Now for sine 180, or sine pi, so hopefully you can see again that that's 0. For 270 degrees, or 3 pi over 2 radians, we have -1. And for 360 degrees, or 2 pi, we are back again at 0. Now, when in the last lesson we learned about radians, I mentioned the angles 30, 45 and 60 degrees. That's pi over 6, pi over 4 and pi over 3. And that's because those are exact values that we can work out as well in relation to trig functions. So if we look at sine 30 degrees, or sine pi over 6 radians, so if we just put those on the graph, so what height is that graph when x is 30, or theta is pi over 6? And that, you might be able to see that there is a half, or 0.5. So that's one of our exact values that we need to know as well. Now if we look this time at sine 45 degrees, or sine pi over 4. Now this one isn't quite as easy to spot at all. So the exact value for those is 1 over root 2. Okay. And finally, for sine of 60 degrees, or sine of pi over 3, again, not the easiest to spot, but you can see it's getting closer to 1 there. So it's a bigger value than the half or the 1 over root 2. And the exact value for that is root 3 over 2. We'll come back to these at the end, because this is something you need to learn. You just need to know these off by heart, because they will come up in the non-calculator paper in the exam, and you just need to know them. And obviously, if you're having to dive for your calculator every time you get, for instance, sine 45, if you're having to constantly look at your calculator, it's not an efficient use of time. Like if you just know this in your head, if you know that sine 45 is 1 over root 2, and you can write that down straight away, well, that's a time saver, especially in the exam. Now, we know, as with the three trigonometric functions that the sine graph repeats itself. So here I've shown you 3 cycles of the sine graph, so between 0 and 360 or 2 pi, and then it repeats itself again and repeats itself again, and it keeps going up to infinity, and it goes backwards as well to negative infinity. So if I wanted to find out what sine 390 was, say, which is around here, what height is that? Well, if I subtract 360, I know that sine 390 has the same value as sine 30. Likewise, if I wanted to know what sine 750 was, which is around here, I can subtract 360, subtract 360 again, and I get back to 30 degrees, which is sine 30, which I know was a half. Likewise, if we get sine 180, which was here, that is the same as sine 540 and sine 900 degrees. Obviously, it'll be the same for radians as well. Let's look this time at the cosine function. So here's the cosine function in degrees, and here we have it in radians as well. So same graph, just that we can see that instead of 90, 180, 270 and 360, we've got pi over 2, pi, 3 pi over 2 and 2 pi. Right, so let's go through the same process as we did with the sine function. I'll go through it a bit faster because you hopefully know where this is going now. So for cos 0 degrees or cos 0 radians, we can see that the height of the graph is 1. For cos 90 or cos pi over 2, we can see the height is 0. Cos 180 or cos pi, you can see it's negative 1. Cos 270 or cos 3 pi over 2, we can see it's 0. And finally, cos 360 or cos 2 pi is 1. Now we'll go through the same angles as we did earlier. So we've got cos 30 or cos pi over 6, which is about here. So it's quite close to 1, not quite 1. And that is root 3 over 2. Now, you might recognise that because we met that in the sine function as well. So we'll come back and chat about that later. Cos 45 or cos pi over 4. And that is 1 over root 2. And again, you might recognise that as well. And we'll come back and chat about it later. And finally, cos 60 or cos pi over 3. You might be able to see this one, that is a half. And like the sine function, the cosine function repeats itself. So after one cycle, there comes many more cycles. It just depends on the range of the x values that you're shown in your graph as to what you can actually see at the time. So obviously if I wanted any bigger values or smaller values and they were equivalent to what I've got here or here, then I know those exact values as well. So for example, cos of 405 degrees. So if I subtract 360 from that, from 405, I get 45. So cos of 405 degrees is also 1 over root 2. Finally, we'll look at the tangent function. So you might remember this graph from last year. So we've got asymptotes here, that's the red lines, and asymptotes are where the curve gets very close to that red line, but it never ever hits it. So we'll talk about that more in a wee minute. And here's the tangent function in radians as well. So we'll go through all the same values. So tan of 0 degrees or tan 0, we can see the height of the graph is 0. Tan 90 or tan of pi over 2. Now that's those asymptotes I was talking about. So if you remember here, that the curve gets really close to that line x equals 90, but it never ever hits it. Same here, this comes down, gets really close, and it never ever hits it either. So actually tan 90 or tan pi over 2 is undefined. And you might remember when we looked at the straight line, topic and we met the formula for gradient, m equals tan theta. Remember, we looked at the gradient of a vertical line and we knew that a vertical line made the angle 90 with the x-axis, but every time we put tan 90 into our calculator we got a math error, and that's because vertical lines have an undefined gradient as well. So there's links here to the straight line. Now if we just look at 270 at the moment as well, or 3 pi over 2, you can see the same thing happens there. The curve gets very close, but it never ever hits that line x equals 270 or x equals 3 pi over 2. So that's also undefined. Tan 180 or tan pi, you can see the height of the graph is 0. Tan 360 or tan of 2 pi, again you can see the height of that is 0 as well. Now let's look at tan 30 this time, or tan of pi over 6. Again, not that obvious what this exact value is going to be, so it is 1 over root 3. We now look at tan 45 or tan pi over 4. You might be able to see from this one here that that is around 1. So if that's 10, this is going up in 2s here. So you might be able to see that that's 1 for the exact value. And finally, tan 60 or tan of pi over 3 is here, and that is actually root 3. So I would hope that for the sine, cosine and tangent functions you would know the exact values of 0, 90, 180, 270 and 360. You should be able to know those from a quick sketch of the graph and just seeing what they are. But we are also expecting you in higher to know these as well. So I keep focusing in on 30, 45 and 60, or pi over 6, pi over 4 and pi over 3, and that's because they're really, really important. So what I would do just now is, if you're in class, obviously we will give you a copy of this to put into your jotter or on your bedroom wall, somewhere that you're going to see this often and you're going to remember them. Or if you're at home just now and you're home learning, if you can take a copy of this down and make sure that you learn it and you put it somewhere where you're going to see it a lot. It might seem like a lot to learn because you need to learn the three values for each of the 3 functions and remember which is which. But you'll get to know it quite quickly. You'll notice some similarities between them. So I suppose sine and cos 45 or pi over 4, those are the same. You'll notice that sine 30 is the same as sine 60, or rather sine pi over 6 is the same as cos pi over 3. And you'll notice that sine 60 or pi over 3 is the same as cos 30 or pi over 6. So actually, if you learn the values for sine going forwards, you've actually learned cos going backwards in a sense. So there's different ways that you can try and remember this as well. Tan, unfortunately, doesn't have any similarities to the other 2 as such. But if you remember that tan is sine over cos, so a half divided by root 3 over 2 gives you 1 over root 3. And for this one, we can see that 1 over root 2 divided by 1 over root 2 is 1. And finally, root 3 over 2 divided by a half gives us root 3. So I suppose if you could just learn the sine values. That gives you cos backwards, and then you could work out the tangent ones, but it would cause you time in an exam situation, so you're better just knowing all 9 of them as best you can, and we'll test you in that in class and make sure that you know them just at the click of a finger. Okay, so like I said, if you're not in class just now and you're doing this at home, can you make sure you get a copy of this and make sure you learn it.